Good day, class. It's Sir Capistrano again, and welcome back to another discussion here in Math 1 Statistics, wherein for today we'll be talking about shapes of distribution, wherein we'll be looking into kurtosis, skewness, outliers, and backslot. We actually in this course or in our subject, we already talked about the different shapes of distribution wherein we talk about distribution that are right skewed, left skewed, and symmetrical. But for today, we will be looking into how we can actually quantify that skewness or that shape of distributions. So not just by merely looking into the graphs or the histogram or the distribution itself. By for today, we'll be using all of our measurements. By our measurements, we will be using the measures of central tendency, we'll be using measures of location, and measure of dispersion to actually look into the shapes of distributions. So in that, we will actually start with the discussions of shapes of distribution and on kurtosis. And by kurtosis, it actually came from the Greek word kyrtos or kurtos, which means bulging. And by bulging, it just means kung gaano ba kababa or gaano ka tambok or gaano kataas yung ating distribution. So in statistics, kurtosis is actually a statistical measure used to describe the relative peakedness or flatness of the distribution. Therefore, we will be looking at the bulge. Okay? And kurtosis is actually computed using this formula, wherein kurtosis is equal to this formula, as you may see here. So we have here this whole quantity using the sample population, or what we call the number of observations. And we have here the summation of the difference, or the summation of the, the fourth power of our observation minus the mean divided by the standard deviation minus this quantity uh, using the sample mean also. So we have here our kurtosis. As you may see here, this is actually one of the longest formula that we actually encountered in statistics. Uh, one of the longest formulas here in statistics. But basically, if we are to compute for the kurtosis, we will actually be quantifying what we call the thickedness or the flatness of the distributions. And that thickedness and flatness is actually categorized into three types of kurtosis. And those type of kurtosis is we have here our leptokurtic. This is a distribution where values are clustered heavily in the center. Meaning to say it is so, yan. We have there a distribution wherein we will be having a higher distribution. So it is quantified by the kurtosis number, wherein if we have a kurtosis that is actually greater than zero, it denotes that a high degree of pickedness. Meaning to say, any kurtosis that is actually larger than zero may be considered as leptokurtic. And we also have there the mesokurtic. By mesokurtic, it is the intermediate distribution which are neither too peak nor too flat, wherein the values are immediately distributed about the center. Meaning to say, there is some degree na hindi siya flat, hindi rin siya thicked. So this kurtosis actually has a value of zero. And lastly, we have here the platycortic. So the platycortic is compared to mesocortic and leptocortic is a flat distribution which values are more evenly distributed about the center. By evenly distributed, kalat or dispersed yung mga values natin. Hindi siya heavily concentrated around dun sa mean natin. So ano ba yung sinasabing heavily concentrated about the mean? So if we say that we have here the symmetric distribution, meaning to say our mean is actually located at this x value. Okay? So, meaning to say, if we have a left-quartic distribution, most of our observations are actually focused or near our mean. If we have mesocortic, we may have observations that are still further away from that mean, and lalo na kung platycortic. So, for platycortic kurtosis, our kurtosis actually has a negative value, which notes a low degree of wickedness. So that is our kurtosis. So, by kurtosis, in the shapes of distribution, ito lang yung pagiging bulge, yung bulge ng ating distribution. And that bulging is affected by the clustering of our observations about the center, or what we call our mean, which is actually stated in our formula here, wherein we have there our mean, and we have here a measure of dispersion, which is our standard deviation. So those are the three types of kurtosis: leptocortic, mesocortic, platycortic. Okay. So this next part, or this next portion of looking into the shapes of distribution has nothing to do with the wickedness. So this is we actually finished discussing this part of shapes of distribution, wherein we talked about the relationship of the mean, the median, and the mode in the shapes of our distribution. So this is what we call skewness, and by skewness, or the coefficient of skewness, measures the general shape of the distribution or the lack of symmetry of distribution. So, yung titingnan lang natin dito about the mean, kung mas marami ba yung values na nasa left side ng mean or nasa right side ng mean, or yung mga values ba ay nakakoncentrate sa mean natin. So, the ranges uh, our skewness ranges from -3 to +3. Right? That number is actually related to the uses of our standard deviation. But in any case, when we measure, or when we compute skewness, skewness may only have a value of -3 to +3. So it relates the difference between the mean and the median to the standard deviation. So long tails of the distribution relates to the direction of the distribution. Ibig sabihin, kung meron kang long tail na nasa right, ibig sabihin lang nun, right skewed or positively skewed yung distribution mo. At kung yung long tail mo naman ay prominent sa ating left, that means that you have a negatively skewed or a left skewed distribution. So, yan lang yung sinasabi natin. Ano ba yung sinasabi nating tail? So, if we have this x, and we have this distribution, wherein you have a longer tail on your right, this will be our right skewed or positively skewed distribution. So ito yung positively skewed distribution. And if you have here tail sa left side, so you have here a negatively skewed distribution. Okay? So, ano ba yung sinatawag nating tails? So, yan yung tail natin dito sa right skewed. Ito yung tail natin sa left skewed. Okay? Actually, dalawang tails yan. Left and right yung tails natin. So, pag yung tail ay nasa right, ibig sabihin right skewed siya. Mas mahaba yung tail sa right. That means that is right skewed. And kapag mas mahaba yung tail sa left, that is left skewed. Pero paano kung hindi natin kita yung shape ng distribution? Paano natin malalaman yung skewness ng ating distribution kung hindi natin nakikita yung graphs nila? So, in there, we have this three types of distribution that we already uh, discussed prior to our discussion of measures of dispersion and measures of location. So in here, these are the three types of the distributions we have. We have the symmetrical distribution, wherein data are evenly distributed on both sides of the mean. It just means that this is unimodal. Mean, median, and mode are actually equal to each other. And we also have here the positively skewed. or the right skewed distribution, it is a distribution wherein the mode is less than the median and the mean, meaning to say our distribution would look like this, having x values here. And for the negatively skewed, we have here this shape for our values of x, wherein most of the data falls to the right of the mean or group higher at the end of the distribution, higher end of the distribution. So tail is to the left. Mm-hmm. That should be east to the left. Sorry for the typo. Alright? So those are the types of our distribution. But again, for this one, this actually looks like we need to consider the shape. Tinitingnan natin yung shape. So, paano natin to actually maka-quantify? So, for the quantification of skewness, we actually will be looking again, shapes ulit. So, these are the negatively skewed, the positively skewed, and the normal or no skew or yung symmetrical natin. So, how about the computation? So, for the computation, we will be actually looking into two types of skewness. We have there the Pearson's coefficient of skewness, and we have the software coefficient of skewness. So for the Pearson's coefficient of skewness, we just need to first quantify our mean, our median, and our standard deviation, and we will be having data or quantity that will tell us kung ano ba ang type ng skewness meron tayo. That is also the same for the software coefficient of skewness, and both of this skewness actually uh, has values that ranges from -3 to +3. And those interpretation are as of follows. Okay? So we have here -3 to -1.5 is negatively skewed. If we have -1.5 to -0.5, that will be slightly skewed or somewhat negatively skewed. And if we have zero point 0.5 to zero point 0.5, that is approximately symmetric. And if we have an skewness that is actually equal to zero, yun ang sasabihin natin talagang symmetric. And if we have skewness that is equal to zero point 0.5 up to 1.5, that is our negatively skewed. And if we have skewness that is greater than or equal to 1.5 to 3, we have there a positively skewed distribution. So let's have an example. Say we have a mean that is actually, let's say, mean of 6.2. Then we have median that is 6.5. And we have standard deviation which is equal to zero point 0.5. Using dispersion coefficient of skewness, we can actually just substitute the values of our mean, median, and standard deviation to our formula wherein we will have there 3 multiplied to our mean which is 6.2 minus our median which is 6.5 over our standard deviation which is zero point 0.5. So as you can see here, we have there 6.2 minus 6.5, that will be 3 times negative 0.3 multiplied to 0.5. So that will be 3 times zero point, negative 0.3. So that will be negative zero point 0.9. Then negative zero point 0.9 divided by zero point 0.5 will be 1 point something. So we have there 3 times negative 0.3 divided by zero point 0.5 or zero point 0.5. So that will be 1.8 or negative 1.8. Okay? So having negative 1.8, okay? So hahanapin lang natin siya rito sa ating interpretations. They fall under -3 to negative 1.5, meaning to say this data or this distribution is actually negatively skewed. Okay? So let's check if that is also true using the software coefficient of skewness. So for the software, coefficient of skewness, ayun nga lang. Kailangan na natin ng n. And for that, hindi natin siya mako-compute dito. But for the software coefficient of skewness, kailangan mo mismo ng data. Kailangan mo ng distribution mo bago mo siya mako-compute. And also, you need to account for the sample size and your excess. So, this will be useful kapag hindi mo na kailangang i-compute yung iyong mean at ay hindi mo na kailangan yung i-compute yung iyong median. If you have your mean and then your standard deviation and you have your data array, the software coefficient of skewness will be your choice of uh, measurement of skewness. And in that, these skewness are actually available in Excel, but hahayaan ko na lang kayong alamin kung paano nyo i-access yung measurement natin ng skewness. But also, that is also the same for the kurtosis. Our spreadsheets actually have a formula for kurtosis and skewness. Okay? So that tells us about the quantification of the shapes of our distribution. Okay? So other additional information regarding the shapes of distribution is we have this example. May example pala tayo. Okay. So, pakita lang natin or gawin lang natin to. Let's compute for the skewness. A motorcycle dealership pays its salesperson a salary plus commission on sales. The mean monthly commission is 8,800 with a median of 9,000 and the standard deviation of 1,200. Determine the coefficient of skewness and determine the shape or the skewness of the distribution. So for the coefficient of skewness, as you may have remembered, we'll be using SK. And since ang ibinigay lang sa atin ay yung mean, this is our mean, that is our mean, this is our median, and we also have this standard deviation or sample standard deviation. We are to compute for the coefficient of skewness. For this, we'll be using the Pearson coefficient of skewness, wherein our formula is equal to our 3 multiplied to our mean minus our median divided by the standard deviation. So, using this given, we will have here 3 times 8,800, second, 8,800 minus 9,000 over standard deviation of 1,200. Okay? So, we will have here 3 times negative 200 divided by 1,200. And if I'm not mistaken, this will be equal to negative 0.5 because we will have here negative 600 divided by 1,200. So we have there negatives 0.5. And this falls under slightly. This is the coefficient of our skewness. So the coefficient of skewness, sorted ko na lang class, is negative 0.5. And the distribution is slightly negatively skewed. Okay? So that will be an answer for that example. And hindi ko chinek kung meron bang ano to. So ayan. So ayan yung solution natin. So hindi niya sinulat yung or hindi ko nag-type yung shape ng distribution. So yung shape ng distribution natin ay slightly skewed. So check lang natin ano. So we have there 0.5. So ayan siya. Dito siya. Okay? Okay. So, for the outliers ay paulit-ulit ko nang binabanggit sa inyo dati. Ano? So, by paulit-ulit ko nang binabanggit sa inyo dati, as you may have remembered when we are talking about standard deviation, variance, mean, lagi nating sinasabi that those measures are actually affected by extreme values, extreme small or extreme large, extremely large values. And for that, those values can be actually called as outliers. So an observation point that is distant from other observation or an observation that lies outside the overall pattern of the distribution. So, it may indicate experimental error if nagkaroon kayo ng outliers. And they strongly affects some measures like the mean and standard deviation. Siyempre, pag affected yung standard deviation mo, affected din yung variance mo. So, in this, we will be actually using the measures of location. And by measures of location, to be specific, we'll be using our first quartile and third quartile. Nakikita niyo na? These topics are actually extensions of our discussions regarding measures of central tendency, dispersion, and location. And for that, we can actually quantify our outliers using these rules. So kapag mayroon kang data na ang value niya ay less than sa first quartile minus the 1.5 of the IQR. Again, in third quartile range is just the difference between first quartile and the third quartile. And is greater than the third quartile plus 1.5 of the IQR, then it is a mild outlier. Okay? So, also, if you have, say, this, uh, ayun. Bali, in symbols lang tong next, no? Wherein kapag meron kang x that is less than the Q1 plus 1.5 of RQR or yung x mo is greater than Q3 plus 1.5 ng IQR, then it is a mild outlier. So if you have a data that is less than Q1 minus 3 times the IQR or greater than Q third quartile plus 3 times the RQR, it is called an extreme outlier. So, dyan natin maka-quantify yung ating outliers. So, for the example, we have here, we have to arrange the data in ascending order. So, arrange in, ayan. So, may formula naman. Then, we need to get the first quartile and the third quartile. Then, we will be using the formula to identify mid or extreme outliers. So, in here, we just need to write the data array there. So we will have there 7, 12, 15, 15, 16, 17, 17, 18, 19, 20, 20, 20, 22, 20, 22. Then we need to get the first quartile, the second, the third quartile. So, so hindi ko kinumpute. So for the first quartile, as you may have remembered, we just need to get our 1 times n plus 1 over 4. And for the rank value, that is also the same for our third quartile. We will be using the 3n plus 1 over 4. And for that, since we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 plus 1. So we will have here 1 uh, plus times 13 plus 1 over 4. So this will be 12. 12 divided by 4, ay, not 12, that should be 14. 14 divided by 4 will be, let me just check, it's 3 point something. 14 divided by 4 is 3.5. Okay. Then for the Q3, we have here 3 times 13 plus 1. So that will be 14 times 3 divided by 4. 14 times 3 divided by 4 will be 10.5. You know, 0.5. But anyway, so we just need to locate 3.5. So dito tayo sa data array natin, we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 11. So, for our first quartile, andito siya sa gitna. And since both 15 to, our first quartile, hindi ko na interpolate class ha. So, pero kung interpolate nyo, ganito magiging itsura niya. Lower value, we have there 15 plus uh, 0.5 fractional value natin nung sa position, sa rank. Then we have there 15 minus 15, which is actually 0. So, 0 tong buong to. Kaya, ang first quartile natin is 15. So, for the third quartile, same scenario. Lower value natin is 10. So, we have there 10 pala. So, we have there 20 plus fractional value, which is 5. So, we have there 0.5 20 minus 20, and 20 minus 20 is 0, meaning this is all 0, so this is actually equal to 20. So now, let's quantify the mid and extreme outliers. So, simulan natin doon sa ating first quartile. So, para doon sa identification ng ating mild outliers, ang sabi nung sa definition natin, it must be the first quartile, less than the first quartile minus the 1.5 of the IQR. Again, hindi pa natin na-compute yung IQR. So, IQR will be third quartile, which is 20, minus 15, the first quartile, which is equal to 5. So, and also, we have there, solve na natin. So, first quartile is 15, minus 1.5 of IQR, which is 5. And 1.5 of 5 is actually uh, 7.5. So, we will have there 7.5. So, we'll have here 15 minus 7.5 will be 7.5. And for the upper part of our mid outlier, we will have here Q3 plus 1.5 of the IQR. Okay, so same scenario, we will have here Q3, which is 20, plus the 1.5 of 5, which is actually 7.5 ulit. Then we will have here 27.5. It just means that our mild outlier will be x's that are less than 7.5 or x's that are greater than 27.5. And as you can see here, wala tayong ganong values. Ay, meron pala. Okay. Less than 7.5 and we have here 7. So that is one of our mid outliers. Bakit natin consider na mild outliers yung ating 7? Kasi 7 is less than 7.5. Do we have values that is greater than 27.5? None. So meaning to say we have here mild outlier, which is actually 7. So that is 1. So how about the extreme outliers? So, kung makikita nyo, wala tayong mild outlier dun sa upper bound. Pero kung gusto nyo i-compute, what you need to do there is just, let me just remove this para lang dun sa computation natin. What will happen here is for our extreme outliers, lagay ko na lang na EO, hindi po yan yung ating executive optical. This is extreme outliers. So for the extreme outliers, our lower bound will be actually Q1 minus 3 times our IQR. Okay? So that will be 15 minus 3 of 5. That is actually 15 minus 15. So that is 0. Meaning to say all of our x's that is actually less than 0 will be an extreme outlier. And as you can see here, wala naman tayong ganong value. And for the upper bound, we have here Q3 plus 3 times the IQR, which is 5. So we'll have here 20 plus 3 times 5. So we have here 20 plus 15. So that will be 35. And for that, we must have extreme outliers will be greater than 35. Okay? So for our extreme outliers, our x's that are less than 0 and greater than 35 are extreme outliers. And as you can see here, we don't have any extreme outliers here because we don't have any observation that are less than 0 or greater than 35. So that is how we compute for the outliers. So in that, since we are done looking into quartiles, IQR, median, and outliers, I'll be introducing this box plot, or what some called box and whisker plot. So again, this is introduced by John Wilder Taki in 1970s. I'm not sure if it is the same John Taki that developed our stem and leaf plot, but it is introduced by John Wilder Taki in 1970s. Mind checking class, pakicheck lang kung same person ba sila. And also, this graph shows or give an approximate observation on the skewness or the distribution, whether they are approximately symmetric, whether they are positively skewed or negatively skewed. So, paano mangyayari yun? So, it is about gawa lang makukuha natin yun or makikita natin yun using this line sa loob ng box natin, wherein if our box is or this line moves to the left, that will be positively skewed, and kapag nag-move siya papunta rito sa right, then that will be negatively skewed. So bakit ganon? Kasi it has something to do with the distribution or the concentration of our observations uh, about the median or our second quartile. So in that, paano ba natin yung gagawin? So, or ito muna pala. This is actually what do you call this? The information that we can get from the box plot. If the median is near the center of the box, it just means that our distribution is approximately symmetric, just like our example earlier dun sa box plot natin. If the median falls to the right of the center of the box, then the distribution is negatively skewed. Meaning to say, our tail is actually longer at the left side of our distribution. And if the median falls to the left of the center of the box, then the box is positively skewed. If the lines are about the same length, the distribution is approximately symmetric. So, ano yung line na tinatawag natin doon? Itong sa x lowest natin at sa x highest. Also, if the line is about the same length, the distribution is negatively skewed. Bakit hindi nagbago? This should be if the line, the right line, sorry. That should be if the left line is larger than the right, the distribution is negatively skewed. Okay? If the line is larger than the left line, then the distribution is positively skewed. So, yun lang yung pwede nating tingnan. Again, this is another way of looking into the shapes of the distribution when we are not considering our bell curve or yung tinatawag natin, yung pinakita natin kanina before we discuss the skewness or the quantification of skewness. Okay? So how do we go about this? So in creating a box plot, you need to arrange the data in ascending order. So pakita lang natin kung may data array ba tayo dito. So the same data that we used earlier. So we need to get the first quartile, the second quartile, and the third quartile. Then we need to locate the lowest possible value. At the lowest value, the Q1, median, the third quartile, and the highest value on the scale. So draw the box around the first quartile and the second quartile and draw a vertical line through the median and construct upper and lower values to the box. So, paano natin gagawin yan? So, na-compute na natin. We already compute earlier for the Q1, for this distribution wherein we have there 15. We also have our Q3, which is actually equal to 20, right? So this will be our lowest value. This will be our highest value, okay? And just need to compute for the second quartile. As stated earlier, we have here 13. So our Q2 will be 2 times 13 plus 1 all over 4. So we'll have here 28, because we have here 14 times 2. 28 divided by 4. This will be actually equal to 7. So we have here 1, 2, 3, 4, 5, 6, 7. So our median is 17, or our second quartile is 17. Okay. So now, let's construct the box. But before that, so para mas makita natin class yung yung use ng ating box and whisker plot, we also need to add another step here. So, uh, in this fifth step, we need to identify outliers and represent them as dots instead of line. So, in that, kanina nakita natin na meron tayong mild outlier dito sa distribution na to, at yun ay identified natin, yung 7. So, in that, hindi natin siya i-consider na lowest value natin para dito sa box plot, and instead, we'll be using 12 as our lowest value. So, maiintindihan nyo kung bakit later on. So, in here, gawa lang muna tayo ng x-axis. Dito ko gawin sa taas, para mas kita natin. So, gawa lang tayo ng x-axis dito. And our lowest value na nandito ay 7. So, I can actually start at, say, 5. Let's end it at 25. Parang mahirap yun. Start na lang tayo sa 0. We have here 0. We have here 25. Okay? So, end tayo sa 25. So, meaning to say, divide ito sa 5. 1. Okay, approximate na lang. Nope. Ayoko. So, let's do this again. Gawin nating 0 to 30. Okay? Para magkaroon tayo ng mas okay na hiwa or na hati. Okay, so we have here 30, meaning to say this will be 15. And then divide this into 3. So we'll have here 5, 10, then we have here 20, 25. Okay, so yan yung graph natin. Pwede ko nang tanggalin yung, no, pwede naman. Tanggalin ko na yung 0 at yung 30. So yun yung x-axis natin. Then ang sabi niya, we just need to locate our lowest value. So our lowest value ay nandito 12 dito. Okay? So this is 7, this is 12. Okay? Then Q1 which is 15. So swerte, andito siya. Ito yung Q1 natin. Q1. Okay? Then Q2 which is 17. Napaliit pala. And we have yung Q3 natin which is 20. Tapos, highest value natin ay 22. Okay? So, ang gagawin lang natin daw, we just need to draw a box through our first quartile and our third quartile. So, we just do a box there. So, this will be our Q1, this will be our Q2, Q3. Then, we have a median here, which is here, 17. So, that will be our Q2. Highest value natin ay 22. So, dyan mag end yung highest value natin. And for this one, we will have this lowest value. Tapos, we have here a mild outlier, which is 7. So, that will be our box plot. So, hopefully, nakita nyo ng maayos kasi medyo maliit siya sa ating box. But, however, you just need to locate all of these values, your lowest value, your first quartile, median, or our second quartile, third quartile, the highest value on the scale, and you need to draw a box around Q1 and Q3. Then draw a vertical line through the median and uh, connect the upper and the lower values to the box. And in case of outliers, you need to represent them as dots instead of member of the line. And as you can see here, this graph or this box plot is actually, since nasa may left siya, this just means that we have here a positively skewed distribution wherein, as you may notice here, we have a longer line here, and we have a smaller box in here. That means we have here a right skewed distribution. So that is our box plot. And in that, I'll just be leaving you this effects of changing units on the measures of dispersion and location. So we have there this differences if we let x1 to xn be our n observations. If we added a constant k to each of the observation or multiplied each observation to a certain number h, where h is not a zero, then ito yung magiging effects natin. Okay? If you already have a range, kung magbago man yun o magdagdag man kayo ng constant, our range is actually unaffected. Same for our standard deviation. Bakit hindi sila affected? Kasi ganun pa rin naman yung dispersion. Ganun pa rin naman ka-disperse yung ano natin, yung magiging observation natin. Kasi we just move our or we just added a certain value of k constant to our observation. And as for the quartiles or any other quantiles, if you added a certain value of k, your new value for quartile, you will be just adding the same constant. For the interquartile range being a measure of dispersion again, it is unaffected. Also, for the multiplication of a certain constant which is not equal to zero, again, our range will actually change. Wherein for the new range, you just need to multiply the value of h. And for the standard deviation, same. You just need to multiply the value of h. For the quartile, same. You just need to multiply that value h. And so is for the IQR. Doon lang tayo magkakaroon ng mga unaffected na values sa ating mga ating measures of dispersion if we are adding some constant k. And kapag nag-add ka ng k sa lahat ng observations mo rito sa x1 hanggang xn, unaffected ang range, unaffected ang standard deviation, unaffected din ang IQR. But if we are multiplying a certain value k, h pala, which is h is not equal to 0, having your original range, you need to multiply h to those values. Okay? And I think that's that ends the discussion regarding dispersion or measures of dispersion and location. So in that, I will be giving you exercises tomorrow uh, regarding our discussions today. So, and another announcement, this actually marks the end of the coverage of our midterm examination. So if you don't have time to finish this video, you would not know that this will be the end of our discussions, or the end of the coverage of our midterms examination. So I will, like our discussion in other subjects, I will still be giving you lessons uh, that will be allotted or be a coverage for our final examination. And that, thank you and have a great day. Bye.